In question 1, we've got the line L1 with equation 2x plus 4y minus 3 is 0, and then the line L2 with equation y is mx plus 7. Now we are told that the two lines are perpendicular, and in part A we need to find the value of m. So starting with the equation for L1, I will make y the subject, so I'll put it in the standard form of y is mx plus c to see the gradient. So the first thing to do is isolate the 4y term on the left hand side, so 4y is negative 2x plus 3. I will divide throughout by 4, so this leads to y being minus 2 over 4x plus 3 over 4. We know that the coefficient of x is the gradient of the line, and therefore the gradient of L1 is negative 2 over 4, which simplifies 2 minus a half. Now we're trying to find the gradient of L2, which is perpendicular to L1, and we know that if two lines are perpendicular, then the product of their gradients is negative 1. So what I will do, I will take the gradient of L1, I will flip it and change the sign, and this means that the gradient of L2 should be equal to 2. Now the lines L1 and L2 meet at the point P, and we need to determine the x-coordinate of the point P. I will start with the equation of L2. Now that we know that m is 2, we've got the equation being y is 2x plus 7. So essentially we are solving simultaneous equations. The first equation is that y is 2x plus 7, and the second equation is 2x plus 4y minus 3 is 0. So I'll be substituting y is 2x plus 7 into the equation for L1. So we're looking at 2x plus 4 times the 2x plus 7 close brackets minus 3 being equal to 0. So we have 2x plus 8x plus 28 minus 3 is 0, which means that 10x plus 25 is equal to 0, and therefore we've got that 10x is negative 25. Now we'll divide both sides by 10, taking me to x is negative 5 over 2, which is the x-coordinate of the point P, the point of intersection between L1 and L2. In question 2, we need to find, using algebra, all real solutions to the equation 16a squared being equal to 2 root a. So the first thing to do here is collect everything on the left hand side. So we've got 16a squared minus 2 root a being equal to 0. I will then proceed by factoring out 2 times root of a. So within the bracket, we've got 8a to the 3 over 2 minus 1, and all of this is equal to 0, which means that either root a is equal to 0, or alternatively, we've got that 8a to the 3 over 2 minus 1 is equal to 0. Now, if the root of a is 0, this simply means that a is equal to 0. And if 8a to the 3 over 2 minus 1 is 0, I will say that 8a to the 3 over 2 is equal to 1, which means that a to the 3 over 2 is equal to 1 over 8, and therefore a is equal to the 1 over 8 raised to the power of 2 over 3. Now, if I plug this on the calculator, I get an answer of 1 over 4, and therefore we conclude that we've got two solutions, a 0 or a is a quarter. Now, alternatively, someone could have started by squaring everything. So 16a squared all raised to the power of 2 is 256a to the power of 4. And on the right hand side, 2 root a all squared is 4a. I will not be dividing by a here because I will be missing out on the a being equal to 0 being one of the solutions. I will instead collect everything on the left hand side. So we're looking at 256a to the power of 4 minus 4a being equal to 0. I will now factor out the 4a. So 4a bracket 64a cubed minus 1 is equal to 0. Which means that either a is 0, or alternatively we've got that 64a cubed minus 1 is 0, taking me to 64a cubed being equal to 1, and therefore a to the power of 3 is 1 over 64. And for me to find a, I will simply take the third root of 1 over 64, which is 1 over 4. Again, the two solutions we found before, a being 0 and a being a quarter. in II, we've got b to the power of 4 plus 7b squared minus 18 is 0. This is a disguised quadratic in b squared. So I will start by introducing w, where w is equal to b squared. Now we know that anything squared is greater than or equal to 0, which means that my w should be greater than or equal to 0. And then w squared is simply b squared, and again squared, which is b to the power of 4. And therefore the original equation in b can be written as a quadratic in w. So we're looking at w squared plus 7w minus 18 is equal to 0, which factorizes into w plus 9 times w minus 2. So this means that we either have that w plus 9 is 0, or alternatively we've got that w minus 2 is equal to 0. Now w being negative 9 is rejected because, as we said, w is greater than or equal to 0. So I'm going to say here reject, not valid. Whereas for the w minus 2 is 0, we've got that w is equal to 2, which means that b squared is equal to 2, and therefore b is plus minus the square root of 2. In 3a, given that k is a constant, we need to find this integral here with respect to x, simplifying our answer. Well, the first thing to do is write this in index form. So we're looking at the integral of 4x to the negative 3 plus kx dx. So in integration, we increase the power by 1 and we divide by the new power. So we're looking at 4x to the negative 2 over negative 2 plus kx to the power of 2 over 2 plus the constant of integration. Now I need to simplify my answer. Obviously the 4 with the 2 simplify to leave me with the 2 in the numerator. So all in all, we're looking at negative 2 over x squared plus kx squared over 2 plus c. In part B, we're asked to hence find the value of k such that the integral from 0.5 up to 2 gives a result of 8. So we know the result of integration was minus 2 over x squared plus kx squared over 2. There is no longer a constant of integration because we're looking at a definite integral, with the lower limit being 0.5 and the upper limit being 2, and all of this is equal to 8. I will start by substituting the upper limit of 2. So we're looking at negative 2 over 2 squared plus k times 2 squared over 2. That's the upper limit substituted. And then for the lower limit, we've got negative 2 over 0.5 squared plus k times 0.5 squared over 2. And all of this is equal to 8. It's time to proceed in simplifying things. So we've got minus a half plus 2k minus, open brackets, the negative 8 plus k over 8, close brackets, being equal to 8. So we're looking at minus a half plus 2k plus 8 minus k over 8 being equal to 8. I will proceed by multiplying throughout by 8, taking me to negative 4 plus 16k plus 64 minus k is 64. So obviously the 64 with the 64 will cancel out. We are looking at minus 4 plus 15k being equal to 0. So I've got 15k is equal to 4, and therefore k is equal to 4 over 15. In question 4, we've got a tree that was planted in the ground. Its height, capital H meters, was measured t years after planting, and exactly 3 years after planting, the height of the tree was 2.35 meters, while 6 years after planting, the height of the tree was 3.28 meters. Now we need to use a linear model, which means we need to fit a straight line to find an equation that links capital H with t. So we have just been given 2 points that lie on the line. The first point is the point with coordinates 3, 2.35, and the second point has coordinates 6, 3.28. I will start by finding the gradient, and we know that the gradient is rise over run. It's y2 minus y1 over x2 minus x1, which is 3.28 minus 2.35. divided by 6 minus 3. This gives an answer of 0.31. And using the fact that the equation of the straight line is given by y minus y1 is mx minus x1, we now have in the place of y the capital H minus the 2.35 is equal to the gradient of 0.31 times x. Well, x is the t here, so t minus 3. I will proceed in expanding. So we've got capital H minus 2.35 being equal to 0.31t minus 0.93, which leads to capital H is 0.31t plus 1.42. Now the height of the tree was approximately 140 centimeters when it was planted, and we need to explain whether or not this fact supports the use of the linear model in part A. So I will start by finding the initial height of the tree as predicted by the model, which simply means I will be substituting t is 0. So when t is 0, we can see from the equation here that this is simply giving me 1.42 for h. So h is 1.42 and this is meters, which is 142 centimeters. And since the predicted initial height with the actual initial height are quite close, we conclude that the linear model is supported. In question 5, we're given the equation of a curve here defined for x being greater than 0, and we need to find in its simplest form dy dx. Well, the first thing to do is write y in index form. So we've got y is 3x squared plus 24x to the negative 1 plus 2. Now in differentiation, we multiply by the power and we deduct 1 from the power. So 3x squared will become 6x. And then the 24x to the negative 1, I will multiply by the negative 1, giving me negative 24. And I deduct 1 from the power, so x to the negative 2. And the plus 2 vanishes. So dy dx is 6x minus 24x to the negative 2. In part B, we're asked to hence find the exact range of values of x for which the curve is increasing, and we know that the curve is increasing if dy dx is greater than 0. Now it's okay if you go with a strict inequality or a relaxed inequality. Both of them are acceptable. So we've got the expression for dy dx from part A, so we're looking at 6x minus 24x to the negative 2 being greater than 0, which I'm going to write as 6x minus 24 over x squared being greater than 0. I will then take the negative 24 over x squared on the right hand side, so we've got 6x being greater than 24 over x squared, and I will cross multiply. And it's okay to cross multiply by x squared without worrying about reversing the inequality direction, because x squared can never be negative. So I'm sure that I'm multiplying by a non-negative number, and therefore the direction of the inequality is not affected. So this takes me to 6x to the power of 3 being greater than 24, which simply means that x to the power of 3 is greater than 4, and therefore x is greater than the third root of 4. Now, if you went with a relaxed inequality, all of these will be relaxed. You will end up with x being greater than or equal to the third root of 4, which is perfectly acceptable for the 2 marks. In question 6, we are given a sketch of the triangle ABC. Now, AB is 3x centimeters long, AC is 2x centimeters long. The angle CAB here is 60 degrees, and we are additionally told that the area of the triangle is 18 root 3 square centimeters, and we need to show that x turns out to be 2 root 3. So I'll be using the fact that the area is a half AB sine C. We know that the area is 18 root 3, which is equal to a half times one side, which is 2x, times the other side, which is 3x, times the sine of the included angle, which is 60 degrees. So we can see that the 2 with the 2 will cancel out. So we've got 18 root 3 being equal to 3x squared, and then sine of 60 is root 3 over 2. Now another simplification I see is the root 3 with the root 3. So if I cross multiply with the 2 over here, we get that 36 is equal to 3x squared. So 12 is x squared, which means that the root of 12 is x. Now I can decompose 12 as 4 times 3, so the root of 12 is the root of 4 times the root of 3, and therefore we end up with 2 root 3 being the value of x as required. In part B, it says hence find the exact length of BC, giving your answer as a simplified third. So looking at the diagram, I will go back and update the length of AB and AC with the value of x we just found. So for AB, we are looking at 3 times the 2 root 3, which is equal to 6 root 3, while for AC, I've got 2 times the 2 root 3, which is equal to 4 root 3. And I will proceed with the cosine rule. So we've got BC to the power of 2 being equal to 4 root 3 squared plus 6 root 3 squared minus 2 times 4 root 3 times 6 root 3 times the cosine of 60. Now I can plug everything here on the right hand side on the calculator. This gives an answer for BC squared, which is equal to 84, and therefore BC is the square root of 84, which I can write as root 4 times root 21, which leads to 2 root 21 centimeters for the length of BC. In question 7, we've got the curve C with equation y is k squared over x plus 1 with x in the reals and x cannot be 0, obviously because this will lead with division by 0 and therefore it will lead to an undefined result. K is a constant, and in part A we need to sketch C stating the equation of the horizontal asymptote. Well, let's start with the obvious thing. We've got the vertical asymptote at x is equal to 0, and for the horizontal asymptote we just need to consider what happens to y as x tends to infinity. So as x tends to infinity, so as x grows larger and larger, k squared over x will be tending to 0, and therefore y will be tending to 1, simply because the first term here is going to 0. So we're simply looking at y is equal to 1, which is the equation of the horizontal asymptote. I will also proceed in finding the cut on the x-axis, which means I need to set y to be equal to 0, which means that k squared over x plus 1 is equal to 0, and therefore k squared over x is equal to negative 1, which leads to k squared is negative x, and therefore negative k squared is the value of x at which point we cut the x-axis. And I can therefore proceed. I'm sketching my axis. We've got the horizontal asymptote at y is equal to 1, and the y-axis is my vertical asymptote. So we know that we are cutting the x-axis at negative k squared, so somewhere here. So my graph looks something like this, with the cut on the x-axis being at negative k squared. In part B, we've got the line L having equation y is negative 2x plus 5, and we are asked to show that the x-coordinate of any point of intersection of L with C is given by a solution of this equation here. So we know that the curve C has equation y is k squared over x plus 1. So we are treating this as simultaneous equations in x and y. So we've got k squared over x plus 1 being equal to negative 2x plus 5. I will start by multiplying throughout by x to get rid of the denominators. So we've got k squared plus x being equal to negative 2x squared plus 5x. And I'll be collecting everything on the left hand side, which takes me to 2x squared minus 4x plus k squared is equal to 0 as required. In part C, we're asked to hence find the exact values of k for which L is a tangent to C. So if this straight line L is a tangent to C, it means that the quadratic here will have a repeated solution, which simply means that the discriminant of the quadratic will be 0. We know that the discriminant is b squared minus 4ac. So in our case, it's negative 4 all squared minus 4 times 2 times k squared, and this is equal to 0. So we're looking at 16 minus 8k squared is equal to 0, and therefore 16 is 8k squared. I'll divide both sides by 8 to get 2 is k squared, and therefore plus minus root 2 are the two possible values of k for which the line L is a tangent to the curve C. Question 8 is on the binomial expansion. We are asked to find the first three terms in ascending powers of x in the binomial expansion of 2 plus 3x over 4 raised to the power of 6, and we need to give each term in its simplest form. So let's start with the expression we're given. It's 2 plus 3x over 4 raised to the power of 6. We know that the first term is the constant raised to the full power of 6, and then we've got 6, choose 1, and it's 2 to the power of 5 times 3x over 4, and each time I drop the power of 2 by 1 and I increase the power of 3x over 4 by 1, such that the sum of the powers 5 and 1 will always be equal to the original power of 6. So the next term will be 6, choose 2, it's 2 to the power of 4 times 3x over 4 raised to the power of 2 plus dot dot dot. Remember, we are after the first three terms. So if we plug this on the calculator, we get 64 plus 144x plus 135x squared plus dot dot dot. In part B, we need to explain how we could use our expansion to estimate the value of 1.925 raised to the power of 6. There is no need to perform the calculation, we just need to provide an explanation. So originally we had 2 plus 3x over 4 raised to the power of 6, and somehow I need to figure out a way of estimating 1.925 raised to the power of 6. So it's logical to put this equal to 1.925 raised to the power of 6. The powers will cancel out, and therefore we can proceed by deducting 2 from both sides, leading to 3x over 4 being equal to negative 0.075. I will cross multiply with 4, taking me to 3x is equal to negative 0.3, and therefore x is negative 0.1. This means that setting x to be negative 0.1 into the original expression will give me exactly 1.925 raised to the power of 6. But if I substitute x is negative 0.1 into this expansion here, it will give me an estimate for 1.925 raised to the power of 6, simply because I'm only considering the first three terms of the expansion and not the full expansion. In question 9, for the company that started mining tin on the 1st of January of 2019, now we've got a model to find the total mass of tin that will be mined by the company, given by the equation shown here. Capital T tons is the total mass of tin mined in the n years after the start of mining, and using this model we need to calculate the mass of tin that will be mined up to the 1st of January of 2020. So the 1st of January of 2020 is exactly a year after the beginning of 2019. This simply means that we'll be setting n is 1, and therefore we are looking at t being equal to 1200 minus 3 times 1 minus 20 raised to the power of 2. This gives an answer of 117, and I need to include the units. It's tons because this is a modeling question. My answers need to be in context, so I need to specify the units to claim the mark. We also need to be careful here that the question is phrased in terms of the total mass mined in the n years after the start of mining. So between the 1st of January of 19 and the 1st of January of 2020, we have accumulated a total mass of 117 tons, which is the mass of tin that will be mined up to the 1st of January of 2020. In part B, we need to deduce the maximum total mass of tin that could be mined. Now the prompt to deduce means there is no extensive calculation or working needed. If we observe the form in which capital T is given in terms of n, we can see that the n minus 20 raised to the power of 2 is always greater than or equal to 0. So the total mass of tin mined will always be 1200 minus something positive. So the maximum we can attain, which I'm going to call T max, is obviously going to be 1200 tons. Again, I need to include the units to claim the mark. In part C, we're asked to calculate the mass of tin that will be mined in 2023. So we need to be careful here. We've got 2023 here. We've got 2024 here. we're trying to find the mass of tin that will be mined during this year. So we need to consider what will happen from the 1st of January of 2023 up to the 1st of January of 2024. So the 1st of January of 2023 corresponds to a value of n which is equal to 4, and therefore t is 1200 minus 3 times 4 minus 20 raised to the power of 2, which gives an answer of 432, while the 1st of January of 2024 corresponds to n being equal to 5, and therefore t is going to be 1200 minus 3 times 5 minus 20 raised to the power of 2, which gives an answer of 525, and the difference between these two numbers will give me exactly the mass of tin mined between the 1st of January of 2023 and the 1st of January of 2024. So I will simply do 525 minus 432, which gives an answer of 93 tons. In part D, we need to state, giving reasons, the limitation on the values of n. Remember that capital T is 1200 minus 3 times n minus 20 raised to the power of 2. If I was to sketch the graph of capital T against n, I'll be seeing a sad face parabola. So it would have been something like this. We have already established that the maximum value of T is 1200, and this will be attained when the bracket here is 0. So this will be attained when n is 20. Now we know that capital T is the total mass of tin mined up to that specific year, and since this is the case, it cannot decrease because we keep adding extra mass of tin mined, and therefore we are restricted in being within this range here, which I'm highlighting in red, and therefore we conclude that n must be between 0 and 20. So my final answer here will be 0 less than n less than or equal to 20. In question 10, we've got the circle C with the equation given here, and we're asked to determine the coordinates of the center of the circle as well as the exact radius of C. Well, we know that the circle centered at the point alpha beta having radius r has this equation here. So I'm going to try and put the given equation into the standard form by completing the square. So we start with x minus 2 squared minus 2 squared plus y plus 4 squared minus 4 squared minus 8 is equal to 0, which leads to x minus 2 squared minus 4 plus y plus 4 squared minus 16 minus 8 is equal to 0, which leads to x minus 2 squared plus y plus 4 squared minus 28 is equal to 0, and therefore we arrive at x minus 2 squared plus y plus 4 squared is equal to 28. We can easily conclude that the center of this circle is at the point 2, negative 4, and the radius r is the square root of 28, which simplifies to root 4 root 7, which is equal to 2 root 7. Now the straight line with equation x is k, where k is a constant, is a tangent to C, and we are asked to find the possible values for k. It makes sense to start by drawing a sketch. We've got the circle is centered at 2, negative 4. Now the line with equation x is k is surely a vertical line, and for it to be a tangent, it must be on either side of the circle, just touching on the circumference. So one possible position would be the one shown here on the right hand side of the center, or alternatively on the left hand side of the center. Now if we draw the diameter connecting the two tangents, we can see that we are 2 root 7 away from the center. So starting from the x coordinate of 2, I can either add 2 root 7 and go to the right hand side, or deduct 2 root 7 and go to the left hand side, and therefore we conclude that k is 2 plus minus 2 root 7. In question 11, we are given f of x here, a polynomial of degree 3, and we are asked to prove that x minus 4 is a factor of f of x. Now, one way we can do this is using the factor theorem, which states that if x minus alpha is a factor, then f of alpha is 0. So in our case, we can see that alpha is 4. So f of 4 is equal to 2 times 4 to the power of 3 minus 13 times 4 squared plus 8 times 4 plus 48. This gives me 128 minus 208 plus 32 plus 48, which gives an answer of 0. And therefore x minus 4 is a factor of f of x. Now we need to be careful here. It's a prove that question, so we need to have the conclusion here to claim both marks. If we just stop at the being equal to 0, then we will lose a mark. In part B, we need to hence use algebra to show that the equation f of x is 0 has only two distinct roots. So I will proceed with the long division now that I know that x minus 4 is a factor. So in long division, we're always trying to match the highest order term on the left hand side. So I'll be multiplying x with 2x squared, which leads to 2x cubed minus 8x squared, and I deduct. So the 2x cubed will cancel out, and then negative 13x squared minus the negative 8x squared will give me minus 5x squared plus the 8x plus 48. Then I need a minus 5x here, taking me to minus 5x squared plus 20x, and I deduct once more. And this time I get the negative 12x plus 48. So I need a negative 12 here, which gives me negative 12x plus 48, and therefore we get the remainder of 0 as expected. So at the moment we have decomposed f of x, which was a polynomial of degree 3, it was a cubic polynomial, into the product of x minus 4 and the quadratic 2x squared minus 5x minus 12, which can be further factorized into x minus 4 times 2x plus 3 times x minus 4. Now remember, we're trying to solve the equation f of x is equal to 0, and based on the factorized form we've just obtained here, we've got that x minus 4 is equal to 0, or alternatively 2x plus 3 is equal to 0. We can see that the x minus 4 is a double factor, which means we've got a double root. So for x minus 4 is 0, we get that x is equal to 4. And for 2x plus 3 is equal to 0, we get that 2x is negative 3. And therefore x is minus 3 over 2. And therefore we conclude that f of x is 0 has only two distinct roots. Now figure 2 shows a sketch of part of the curve with equation y is f of x, and we need to deduce, giving reasons for your answer, the number of real roots of the equation 2x cubed minus 13x squared plus 8x plus 46 is equal to 0. So on the diagram here, the equation of f of x is 2x cubed minus 13x squared plus 8x plus 48. Notice we're not looking at f of x here. This is a 46 and that's a 48. We have already established that the cuts on the x-axis are at negative 3 over 2 and 4. So the first thing to do is take this equation here and manipulate it to get f of x to be one of its two sides. So the obvious thing to do is add 2 on both sides. So we're looking at 2x cubed minus 13x squared plus 8x plus 48 is equal to 2. So I have added 2 on either side of the equation. So we're looking at f of x is equal to 2. So going into the diagram here, we can see that if I was to draw the line with equation y is equal to 2, it would have been something like this. And therefore we can see that we've got 3 points of intersection, and therefore we expect to have 3 real roots. So my answer to part C is that we've got 3 points of intersection, and therefore we've got 3 real roots to the given equation. Now, given that k is a constant and the curve with equation y is f of x plus k passes through the origin, we need to find the 2 possible values of k. So we're dealing here with a transformation corresponding to a translation k units to the left. So we're simply deducting k from x. So if we go back to the diagram here of f of x, it simply means that either the minus 3 over 2 comma 0 is now mapped to the origin, or alternatively the 4, 0 is mapped to the origin. So the two original points are here and both of them are mapped to the origin. So in both cases I'm deducting k from x. So negative 3 over 2 minus k is equal to 0, which means that negative 3 over 2 is the first possible value of k, whereas the second possible value of k is given by 4 minus k is equal to 0, which means that 4 is equal to k. In 12a, we need to prove the following identity here. So in these cases, I tend to start from either the left-hand side ending up to the right-hand side, or from the right-hand side to the left-hand side. Now it makes sense to start from the left-hand side because I've got more terms and therefore more options to work with the given expression. So on the left-hand side, we've got 10 sine squared theta minus 7 cos theta plus 2 over 3 plus 2 cos theta. The first thing that comes to mind is to write sine squared as 1 minus cos squared, so that the numerator of this fraction will be a quadratic in cos theta. So the denominator is still 3 plus 2 cos theta. I will proceed by expanding to get 10 minus 10 cos squared theta minus 7 cos theta plus 2. In the denominator, I still have the 3 plus 2 cos theta. And then in the numerator, I collect like terms together to get 12 minus 7 cos theta minus 10 cos squared theta, and all of it divided by 3 plus 2 cos theta. So the numerator is a quadratic in cos, which factorizes into 3 plus 2 cos theta. That's the first bracket. And the second bracket is 4 minus 5 cos theta. The denominator is still 3 plus 2 cos theta, and I notice that these will cancel out, and therefore I'm left with 4 minus 5 cos theta, which is the right hand side as required. In part B, whereas to hence or otherwise solve for x between 0 up to 360 the given equation here, and we observe that the left-hand side is what we have just proved in part A to be simplifying to 4 minus 5 cos theta. So the given trigonometric equation here simplifies to 4 minus 5 cos x being equal to 4 plus 3 sine x. Obviously the 4's will cancel out, so we're looking at negative 5 cos x being equal to 3 sine x. I will proceed by dividing both sides by cos x because I'm trying to get tan x into the game and no other trigonometric ratios. So I've got negative 5 being equal to 3 tan x, and therefore negative 5 over 3 is tan x. I will proceed by finding the principal value, which is given by shift tan of negative 5 over 3. So I'm going to go on my calculator, I press shift tan, and we've got negative 5 over 3. I press the equal sign, I get negative 59.036 dot dot dot. I will store this on my A key, so I'm gonna put an A here. This is holding now the principal value, and we know that when we are solving trigonometric equations involving tangent, the solutions are given by the PV, which is now held at A, plus 180k. So what I'm gonna do, I'm gonna press menu, option 9, table. It's gonna be A plus 180x. I can start at negative 2, I can end at 5. I'm stepping every one. So what I'm doing here is that I'm automating the whole process of generating all solutions to the given trigonometric equation. So I press the equal sign. All of these are solutions. I'm interested for x between 0 and 360. So the first solution is that x is equal to 120.96, and the second solution will be 300.96. Notice that the question did not specify for accuracy, so anything correct to 3 significant figures is perfectly fine. So if you gave an answer of 121 and 301, you will be scoring all 3 marks. In question 13, we're given a sketch of part of the curve with this equation here. We are told that the curve has a minimum turning point at x is k. The region R is the region shown shaded here, and we need to show that the area of R is 256/3 squared units. I will start with the first piece of information, that we've got a minimum turning point at x is k. I will need to use differentiation to find an expression for dy dx. We know that in differentiation we multiply by the power and we deduct 1 from the power. So we're looking at 2 times 3x squared minus 17 times 2x plus 40, which simplifies to 6x squared minus 34x plus 40. Now we know that the turning point means that the derivative is 0. So turning point at x is equal to k, means that the dy dx evaluated at x is equal to k should give me a result of 0. So I will proceed and substitute x is k here. So we're looking at 6k squared minus 34k plus 40, which is equal to 0. It makes sense to divide everything by 2, taking me to 3k squared minus 17k plus 20 is 0, and this factorizes into 3k minus 5 times k minus 4. So one solution is at 3k minus 5 is equal to 0, and the second solution is at k minus 4 is equal to 0, which means that 3k is equal to 5, which means that k is 5/3, or alternatively k is equal to 4. So I can go back to the diagram here. The first turning point is found here and the second turning point is here. So this value here corresponds to the 5/3 and this is the 4. I'm interested in this second turning point, and then to proceed and find the shaded area R, I'll be using algebraic integration with limits being 0 and 4. So let's proceed. We've got R being equal to the integral from 0 up to 4, and the expression for y was 2x cubed minus 17x squared plus 40x, and we are integrating with respect to x. Now in integration, we are increasing the power by 1, dividing by the new power. So we're looking at 2x to the power of 4 over 4 minus 17x to the power of 3 over 3 plus 40x squared over 2. My limits are 0 and 4. Before proceeding and substituting the limits, let me do some simplifications. The 2 with the 4 leaves me a 2 in the denominator. The 40 with the 2 leaves me a 20 in the numerator. I can now proceed in substituting the upper limit. So we've got 4 raised to the power of 4 over 2 minus 17 times 4 to the power of 3 over 3 plus 20 times 4 to the power of 2. This is the upper limit substituted, and if you observe, substituting the lower limit of 0 contributes overall 0 because all of these will simply be 0, so minus 0 here. So this leads to 128 minus 1088 over 3 plus 320, which further simplifies into 256 over 3 as required. In question 14, we are told that the value of a car V pounds is modeled through this exponential equation where the age of the car is t years, and using the model we need to find the initial value of the car. So obviously I need to start by setting t is 0. So when t is equal to 0, we get that V is 15,700 e to the power of 0 plus 2,300. Now the e to the power of 0 is simply 1, and then 15,700 plus 2,300 is 18,000, and we're talking about pounds, so I need to include the unit to claim the mark here. Now, given that the model predicts that the value of the car is decreasing at a rate of 500 pounds per year when T is capital T, we need to show that this leads to 3,925 e to the negative 0.25 capital T being 500, and then we need to find the age of the car at this instant, giving our answer in years and months to the nearest month. So this is the expression for capital V in terms of T. I will start by finding the derivative. I will find dv dt. because the question refers to the rate at which the value is decreasing, so that's the derivative. So we know that the derivative of e to the negative 0.25t will simply be the negative 0.25 times the exponential term. So we're looking at 15,700 times the negative 0.25 times e to the negative 0.25t. This simplifies to negative 3,925 e to the minus 0.25t. This is the rate of change of the value with respect to time. And we are told that dv dt when t is equal to capital T is given by negative 3925 e to the minus 0.25 capital T, which is equal to negative 500. Now the negative here, it's because we are told that the value is decreasing, so the rate of change is negative, hence the negative in front of the 500. So if I cancel out the negative signs, we get 3925 e to the negative 0.25 capital T is equal to 500 as required. Now we need to be super careful here because it's a show that question. If you've got a small t here, you will be penalized. You need to match exactly the printed answer here to claim full marks. For II, we need to proceed in solving the given exponential equation. I will start by isolating the exponential term. So e to the negative 0.25t is equal to 500 divided by 3925, which gives an answer of 20 over 157. So I will take a ln of both sides. So negative 0.25 capital T is a ln of 20 over 157. So if I divide both sides by negative 0.25, we get that capital T is 1 over the negative 0.25 ln of 20 over 157. Now let's go on the calculator here. We've got 1 over the negative 0.25 and we've got a ln of 20 over 157. So this gives an answer of 8.242. Let me write this down. T is 8.242 ... But this is not my final answer. I need to give my answer in years and months to the nearest month. So we surely have 8 years. Let me write this down. So we're looking at 8 years, and for the number of months, I will deduct from this answer the 8 to concentrate on the decimal part. We know that a year has 12 months, so I will multiply this by 12. This gives an answer of 2.90 months. So to the nearest month, it's 3 months. So my final answer for this part of the question is 8 years, 3 months. Now the model predicts that the value of the car approaches but does not fall below £8, and we need to state the value of A. Well, this is the expression for V in terms of t. We will consider the behavior of V as t tends to infinity. So as t grows larger and larger, the exponential term will tend to 0 because the exponent is negative, so this turns to 0, and therefore V turns to 2,300, which leads to the conclusion that A is equal to 2,300. Alternatively, I can go on my calculator, I can substitute a really big value on my answer key and proceed in substituting this within the expression for V. So I've got 15,700 and we've got e to the negative 0.25 ans and then plus the 2,300. So essentially I'm simulating the process of t growing larger and larger. So if I press the equal sign, I get the 2,300, which of course agrees with the answer we obtained through this analytic approach. In part D, we need to state the limitation of this model, and one limitation we could raise is that this model will not work for a classic car where value is expected to increase with time, because this model is only allowing for a decrease in value with time. Alternatively, we could mention that the model does not allow for damages or involvement in accidents that will lead to a sudden significant drop in value. Question 15 is a proof question. We are told to prove that n cubed plus 2, where n is a natural number, this means a positive integer, is never divisible by 8. And we will be using proof by exhaustion here. I will be considering even numbers and then odd numbers, and in each case we will arrive at the conclusion that they are not divisible by 8. So I will start with the even case. So I say consider that n is equal to 2k, where k is an integer. So each even number is 2 times an integer. So this means that n cubed plus 2 is equal to 2k raised to the power of 3 plus 2, which is of course 8k cubed plus 2, which we easily recognize as 2 more than a multiple of 8, and therefore it is not divisible by 8. We will then proceed with the odd case. So we consider now n being 2k plus 1, where k belongs to the integers. So this time n cubed plus 2 is equal to 2k plus 1 raised to the power of 3 plus 2. I can either expand here or I can use a logic approach which says that if n is odd, then n cubed is also odd, and if I add 2, it's gonna be odd again. So there is no chance that an odd number is divisible by 8. I will proceed with expanding though here. So the expansion of 2k plus 1 raised to the power of 3 is giving me 8k cubed plus 12k squared plus 6k plus 1 plus 2, which I can write as 8k cubed plus 12k squared plus 6k plus 2 plus 1. Now from the first 4 terms I will factor out a 2. So we're looking at 2 times 4k cubed plus 6k squared plus 3k plus 1 close brackets plus 1, which is surely an odd number, therefore it's not divisible by 8. All we're missing here is an overall conclusion, and therefore we conclude that n cubed plus 2 is not divisible by 8 for all n in the naturals. In 16i, we've got two non-zero vectors a and b, satisfying that the magnitude of a plus b is equal to the sum of the magnitude of a and the magnitude of b. And we need to explain geometrically the significance of this statement. Well, it makes sense to start by drawing a diagram just to get a sense of what's happening here. I've got the vector a and the vector b. The vector a plus b is the straight line that will close the triangle, and we are told that the magnitude, the length of a plus b, is equal to the sum of the two magnitudes. Well, if this is a triangle, there is no chance that this here, this side here, will have exactly the length of the other two sides added up, unless we collapse the a and the b over the same line here, which simply means that the vector a and the vector b lie in the same direction. Now in II, we've got two different vectors, m and n, such that the magnitude of m is 3, the magnitude of m minus n is 6, and the angle between the vector m and the vector n is 30 degrees, and we need to find the angle between m and m minus n, giving our answer in degrees to 1 decimal place. I will draw a diagram once more just to get a feeling of what's happening here. So I've got the vector m here, the vector n maybe something like this. So the vector m minus n can be thought of as minus n plus m. So I go in the opposite direction of n and then along the direction of m. So it must be the vector here. So I'm drawing this in blue. So what else we've been given is that the angle between the vectors m and n is 30 degrees. We also know that the magnitude of m is 3 units, and we know that the magnitude of minus n plus m, the side here of the triangle, is 6 units. What we have been asked to find is the angle between the vector m and the vector negative n plus m, which is the angle I'm highlighting here. So I'll be using the sine rule here. I will call the third angle over here to be theta. Once I find theta, we know that the angles in a triangle add up to 180 degrees, and therefore we can proceed in finding the missing angle. So let's proceed with the sine rule. We're looking at sine of 30 over 6 being equal to sine of theta over 3. I will cross multiply to get 3 sine 30 over 6 being equal to sine theta. Now if I do shift sine of 3 sine 30 over 6, we get that theta is 14.4775 ... And therefore the angle between the vector m and the vector m minus n will be given by 180 minus the 30 plus the 14.4775. If we plug this on the calculator, we get an answer of 135.5 degrees.